And I'm live. That is pretty cool. So today is 12th of October 2025, Sunday. And yep, we are going to get into Rust. Yes, that and yes, I am taking a little bit of break from competitive programming because it feels a bit too overwhelming right now, currently. So that is Xervia. So yes, I will be taking a little bit of break from that. And yeah, I made a post, and in there, people selected Rust to be the next thing which we should be doing. So that is what we are doing. Democracy. Democracy is the best form of government, except all the rest. Eh, shit, I messed this up so much. Democracy is the worst form of government, except all the rest. So yeah, the main goal with this is going to be to like write basic programs in Rust because I have no idea about how Rust is, what it is, what it does. So yes, that is going to be the basic thing. And if we get a bit too much comfortable with Rust, then we will build something. We will explore OpenGL because I want to write something, anything in OpenGL, just having a little circle on the screen, a little circle would be amazing. Using Rust, putting a little circle on a window would be amazing. So yeah, that would be the next step. But before that, we will just learn Rust. And of course, the main uh, thing is going to be the basic guiding thing is going to be learn X environments. Yep, of course, that is the thing you go to. But if you are a beginner, then you don't do this. Hello, what's up? How is everything going? And your PFP just yellow. That is it. It is just yellow. And we are learning Rust. It is amazing. We are just going to learn Rust. And Rust. Rust is a programming language. Shit. Developed by Mozilla Research. Okay. And Rust combines low-level control over performance. We get low-level control, and we also have performance with high-level convenience and safety guarantees. Safety guarantees is the thing, right? With Rust, memory safety and all that. It achieves these goals without requiring a garbage collector or runtime. And these two things are slow: garbage collection and runtime. I cannot make the argument for runtime, but I can make an argument for for why garbage collection is slow, and making it possible to use Rust libraries as a drop-in replacement for C. And what is garbage collection? Garbage collection is in interpreted language, or in like modern languages, when your program is running, like whatever your program is running, that is the correct spelling for program. When your program is running, it tells the operating system that your program needs some memory, and your operating system then looks at the RAM, right? And your program says, I want some amount of memory. Then the operating system looks at the RAM. This is the RAM, and yeah, gives you some memory. And then it is your program will have address. Your program will have pointers in this RAM, which tell your program which part of the RAM they can access. And this is very simplistic because generally now we have things, literally hardware components. We have literal hardware components called MMUs, memory management units. And what these do is, instead of your OS giving pointers to the literal physical RAM, your OS instead gives your program some virtual memory space. Like your process could think you might actually have a RAM that is just 4 GBs in size, 4 gigabytes RAM, but your OS can virtually create or make your program think that your program has a like full RAM stick to itself, and RAM is, let's say, 400 gigabytes. And then whenever your program wants to access the RAM, your program accesses this virtual memory, VM, virtual memory. And this thing, this virtual memory thing, this does not actually exist. This is just virtual memory. Your program thinks it has a RAM of a big size to itself, but actually it doesn't have anything. So when your program tries to access this virtual memory, it provides a load or store instruction, uh, str or LDR, load or store instruction, with some address. And these kinds of instructions which have to do something with the RAM, these instructions are passed through this hardware component called MMU. And this MMU stands for Memory Management Unit, not plural, singular, unit. And this is like a literal hardware component. This is like, this is not a software, this is a literal hardware component onto your motherboard. And these types of instructions which have to do something with the RAM, these instructions are passed on to this MMU, and this MMU does the translation of these virtual memory addresses to the actual memory, and then your program accesses these memories through this MMU translation. And the problem here is, shit, all of that was not even needed. The MMU part and all the virtual memory part, that was not even needed. But still, here the problem is you might forget to free some memory which you have taken. For example, your program might think, let's say this is some address A1 which your program has, and this has size S, and your program thinks that it has a memory of size S starting from this address A1 in the RAM. And then let's say your program moves on to some place but forgets to tell the operating system, the OS, that the program, your program PR, is not using this memory any longer, and the OS can give this memory to some other program or keep it in reserve. So your program, like you wrote a bad program and your program doesn't tell the OS that this is the memory which you can like use, right? And this is bad because the operating system thinks that this memory is being used by the process, but the process has lost the information. The process does not remember anything about it. And if the process needs more memory, it is not going to use this original memory. The process will ask the operating system for some more memory. And this is just going to be very bad because you will keep taking memory from the OS and you will not give it back. And this is memory free, I think, memory error, and this is problematic. So people came up with the idea of a thing called garbage collection. Garbage collection is garbage collection is looks like a very amazing idea on the surface, but it is not very amazing everywhere. What garbage collection does is, this is a separate program inside your program. And what this program has is, this program has references like whenever you ask the OS for some memory, you get an address, right? Address and size. So because address meaning this is the starting cell in the RAM for this memory, and this is how far you can go from this starting cell to access this memory, and all of this memory is yours. This garbage collector just keeps track of all of these addresses and size. Essentially, it just keeps track of how much memory you have taken from the operating system. And the concept is garbage collection keeps going through all of these in like intervals or depending on whatever, however it is configured, and it checks is this memory still in scope and is being used by something. And if this memory or whatever memory it is checking, if the memory is not being used by the program, garbage collection on the behalf of the program tells the operating system, I do not use I'm not using this memory anymore, take it back. And yeah, it just goes away, and yeah, you have essentially freed the memory. But this is bad. This is like, this sounds very good, but this is bad because garbage collection is a heavy program. It has to go through all of these memory references in fixed intervals, and most of the time you are not even freeing memory, like you are using these memories and there is no need to return anything to the OS most of the time. And at one point it got so bad that 80% of the time it was the garbage collector running. Yeah, this is something Björn Stroustrup, the creator of C++, he said 80% of the time it was the garbage collection which was running, and it was just checking. Maybe let me just see, is there any memory which needs to be freeing, which yeah, which needs to be freed, and it was running the garbage collection. The garbage collector was running 80% of the time. Your main program wasn't even running, it was just running 20% of the time. Most of the time it was the garbage collector running, and that is crazy. That is like literally crazy. And okay, that was garbage collection. Garbage collector. And Rust does not require a garbage collector. So Rust is therefore fast. Python has a garbage collector. JavaScript is very slow. It has a garbage collector. And mostly all of the high level languages have a garbage collector. C does not have a garbage collector. That is why there are a lot of memory freeing errors in C. And C++ does not, I don't think C++, yeah, C++ doesn't have a garbage collector, right? It does not. I mean, it does not have a built-in atomic garbage collector. Yeah, C++. Like other languages, Java has a garbage collector, Python has a garbage collector. Yes, C++ does not, because if you need performance, you cannot be using a garbage collector. Garbage collector is slow. 80% of the time, it is the garbage collector running, and that is bad. That is not very good. So yeah, that was garbage collector, virtual memory, MMU shit. Okay, and let's get back to Rust. Garbage collector make it possible to use Rust libraries drop in. Rust's first release 0.1 in January 2012. 2012 was the year when the world was like supposed to end, but it didn't. Okay, and for 3 years development so quickly that until recently the use of the stable releases was discouraged, and instead the general advice was to use nightly builds. Okay, and stable release is a like release which is supposed to be stable release, and nightly builds is whatever the latest commit is on GitHub, that is nightly builds. On May 15th 2015, Rust version 1 was released with a complete guarantee of backward compatibility, improvements to compile times, and okay, Rust has very high compile times. That is what I know. Rust has very high compile times, and there is a reason for it. And other aspects of the compiler are currently available in the nightly builds. Rust has adopted a train-based release model. Okay, train-based release model is something with regular releases every 6 weeks. Okay, Rust 1.1 beta was made available at the same time of the release of Rust 1. Okay, okay, that was just some things. Although Rust is a relatively low level language, it has some functional concepts that are generally found in high level languages. This makes Rust not only fast but also easy and efficient to code in. And now the actual thing in Rust. Okay, this is a comment line. Yeah, so a single comment line looks like this, and block comments look like this, and they can be nested. Documentation comments look like this and support markdown notation. Okay, now the basics of Rust, and like we are now actually going to learn Rust. This is amazing. This is pretty cool. Hello, I am amazing. How are you? You are awesome, it seems, if that is the correct pronunciation of awesome. Okay, laptop is charged. Yes, we are learning Rust, and yeah, for a few days we will be learning Rust, and this is going to be our main thing. I think we can go through this just today. Yeah, we will be able to write some Rust today, and that will be fun. But before we do this, and shit, yes, shit, there is, we need Rust LSP. I do not have. I do have the Rust LSP installed, but it is not configured. It does not work. It does not work. So I will have to fix that, and that will be amazing. Uh, Rust LSP is Rust Analyzer, and I think I have it. I don't know how to check it, but I think I have the Rust Analyzer, and we will configure it. It will be amazing. And before actually reading what Rust is, I will write hello world in Rust. And I have cargo installed. I I think cargo is the package manager like npm, and Rust C is the Rust compiler. Let's install it or maybe update it. I think I already have the Rust compiler. I just have to update. Shit. Bro install Rust. Okay, now it is working. Rust also uses LLVM. That is, yeah, that makes sense. LLVM. Yo, nope, not for a few days. A little break from code forces, I guess. Breaks are also necessary so that my brain can, like, in the background, process everything that has been going on in code forces. And yeah, breaks are pretty cool. Breaks are pretty cool. When you do not exercise and you come back the next day and you exercise, you are like really good at exercising. I think now if I take a break for a few days, I'll be really good at code forces. And yeah, and in that time, we'll do Rust. Rust. So, what are going to be the goals for today? At least, let's see. Goal number one would be to write basic programs, whatever that means, like however we define basic, and then also set up Rust Analyzer. Rust Analyzer is the LSP for Rust. Yeah, those are the goals for today. Yeah. This step would be amazing because we would get LSP suggestions while writing Rust. That is pretty cool. And this is the main thing, which is going to take us forward, take you forward, TUF. Documentation comments look like this, normal comments look like this, and block comments look like this. And this is how you define a variable using let, just like in JavaScript. Okay, now the basics. Allowed dead code. Okay, wait, what is this thing? Allow dead code. Like you can write code here, but it does not work. I don't know. Functions I3 is the type for integer 32, 32-bit signed integer. Okay, and this is the syntax for function name, and before that fn, just like in Python. In Python we have fun. In Python we have def, define, and then function name. Here the input variables, their type separated by a semicolon, separated by a colon, not semicolon. And this is how we tell what the return type is. Integer 32-bit and implicit return, no semicolon. Okay, this is cool. We can, without writing the return keyword, we can return something from a function if we do not put any semicolon. Rust is on. Okay, we do have the Rust compiler installed. That is amazing. So this is pretty cool. We can return something. Let's use this. And I do know one thing about Rust, that we can use printf, print ln, and exclamation mark, and then whatever we give in, that gets printed to the screen. Let's start tmux. Tmux attach gdb. We are in the gdb folder, it seems. Okay, a new window. How do I create a new window in tmux? Okay, now it is there. Okay. Rust, what have I written in Rust? I have written mem.rs in Rust. Okay, I was trying to do something in Rust at a point. cd Rust. Okay. Hello.rs, that is the extension of Rust. Sync everything, and wait, there is a main function. Yeah, there is a main function. Fn main, and let's practice. Yes, let's write this thing. Fn main, that is how we define a function. And we, to print a line, we use print ln exclamation mark, and then let's say hello world new line. Okay, this should work, I think. Let's see. If we want to compile, we can write rest c hello.rs output out. Okay, it does compile without errors. /out hello world in rest. Wait, shit, we got an extra new line. So does rest add a new line on its own by default? If we remove the new line and compile again, just see hello.rs and run. Okay, Rust does add a new line on its own. That is nice. Okay, this exclamation mark does something. I don't know what, but this does something. We will read it. We will know about it. Okay, and let's write another function which takes in two numbers and returns their sum or product or something. Fn add, this takes in x, which is I32, and y, which is I32, and returns I32 integer and x plus y. And if we do not write semicolon, this should work. This should return. Okay, and okay, I don't know how to format a string, so we will just write this like this. Add 12 and 37, or 37 and 42. Those are the numbers. Should be 79. Let's see. Just see hello.rs. Okay, there is error. Should This is so cool. Okay, this Rust is telling us that the error is here in the print line function, and help. It is helping us. Literally, it is helping us. That is cool. Rust is helping us and telling us you might be missing a string literal to format with. Okay, formatting. When we do normally, when we do like in C, printf, and like sum is a digit, and then we write in the digit, let's say 10, right? This is how normally formatting works. We pass, not normally, this is how formatting works in C++. And this is telling us to format something, we do this. So we have to pass in a string and then this thing inside. I think whenever we, okay, so my idea is that whenever we have this curly braces, and then whatever is here, these things go inside the curly brace. And if we have multiple, like two curly braces, closing and opening, two pairs of curly braces, then the first thing goes into the first one and the second thing goes into the second one, and we can test this theory right here. Print ln exclamation mark and sum is this, or sum of shit. Okay, let's add variables. Let x equals 37. I think this is okay. This should be okay. And then sum of one number and second number is this. And I don't know if this is going to work, but let's see. X and y, and then add x comma y. Let's see. Okay, so here we have three curly braces, and we have given this function three other separate arguments. The first one, x, should go in the first curly brace, and y should go in the second one, and this thing, their sum, should go in the third one. And let's see, not GCC, if it compiles. Just see hello out. Okay, it does compile. It does work. So that is how you do. And look at this thing. Here we haven't given end of line, a new line literal at the end, but still we got a new line. So Rust adds new line on its own. Okay, okay, okay. So we know how to write function, and this is how we tell Rust what is going to be the input type of variables and what is going to be the output type of a function. And I32 is 32-bit integer. That is pretty cool. Hello. It is the same as how formatting works in standard print ln in CPP. Share. Okay. There is a print ln function other than printf. That is cool. Hello. For the problem which you sent at coder problem in the Discord. Yes, that was nice. Okay, so this is the same with that formatting works in print ln, print a line. That is nice. Okay, so these guys copied C++. Okay, allow unused variables. Okay, what do these things mean? What are these comments? Anyways, unused assignments, dead code, main function. Okay, Rust has a main entry point function. Cool. Okay, I think all the compiled languages should have a main entry point function, because how would the binary know which thing to run? Or maybe in a language which does not have a main function like Python, there would be Python compilers which would turn Python code into binary, and whatever we have written top to down, they can make like the first line the entry point of our program and work with that. Yeah, so they don't have to, but it is nice to have it. And then immutable bindings. Okay, shit. Okay, immutable. What does immutable mean? We cannot change this like a constant. And then integer, float. This is integer, I32, and float 64-bit. Makes sense. Makes sense. This is like putting f at the end of an integer in C++, or ll at the end of an integer to make a literal number long, I think. And then type interface. Okay, immutable bindings is crazy. And mutable bindings, they are not telling us what these things are. So this x is supposed to be immutable. And what does immutable mean? If I were to do x equals x plus 5, is this wrong? Is it like constant? Yeah, it is wrong. It is wrong. We cannot change this. This is constant. Shit. So this generally in our language, we have to tell this number is a constant. We cannot change this. And here we have to tell this number is not constant. We can change this. Yo, I didn't see your submission. I just read the problem and entered. Alexander Linder. Hello. I didn't understand what's wrong in my submission. Okay, I will have a look at it. But Rust seems like it wanted to create something like an amalgamation of functional programming with LLD. Okay, I don't know what LLD is. Limited debugger, which honestly makes it unnecessarily complex. I would be able to argue with that when I know a little bit more of Rust, but it wanted, I think the main idea behind Rust was, oh, I always wanted to learn Rust. Rust is like the cool new thing on the block. Low level development. Yep. Low level things are like amazing, always cool, very cool. And okay, when I know, yes, I think the main idea with Rust was to prevent memory leaks caused due to C and C++. I think that was the main idea, to make Rust memory safe. So that, yeah, okay. And I will be able to say more when I know a bit more of Rust. Again, this thing is very cool. We have to say specifically, specifically that we can change the current number. Let mute x equals 37. That is cool. And now we should not get any error. And this thing is saying cannot assign twice to immutable variable. Shit, that is so cool. Normally we have to say this number is constant, this variable is constant, we cannot change it. But here we have to say this number, this variable is not constant, we can change it. They are helping us consider making this binding, mutable. Binding is the word they use for variable. Okay, and if we do make it mutable, rust c hello.rs. Okay, it does compile. And we got, shit, I by coincidence added 5 and that made the both of the numbers equal. That is coincidence. Okay. Low level development. Yo, low level development is cool. Hello, what's up? How is everything going? Noah the Ark. Noah of the Ark. Provenzano. Noah Provenzano from Soviet Union. Printel and C++ was added in C++23. Shit. So, shit. Okay. They copied it from Rust. Hello. You like Rust? I also like Rust. And yeah, I just don't know Rust. And yeah, we are going to learn about Rust. And shit, if for a few days, I'll be here learning Rust on stream. And for today, the main goal is to go through learn X and Y page for Rust and set up Rust analyzer. So we get some LSP and some help. And then it would be to get into graphics, learn OpenGL in Rust and write something, maybe just a little circle or a square on the screen would be very amazing. If you could just make a square on the screen, that would be pretty cool in Rust. Awesome. Bro, do you take break? Yes, I am taking a break today. Today is a break stream. I'm not doing competitive programming today. This is break. This is fun. And Friday the 13th. Okay, let's move forward. And this is cool. Okay, so these guys copied, or C++ more like copied from Rust. That is okay. And Linux kernel is also being rewritten in Rust. GitHub, Torvalds, Linux. This is also, yeah, yeah, kind of being rewritten in Rust. 0.2%. They have a specific like folder which has Rust. Yes, directory, not folder. My bad. Bindings here. Why do we have C? .c in Rust? That is crazy. Compiler built-ins, FFI. Okay, I don't get this, but yeah, okay. With this, okay. Yes, here we were. Most of the time, the Rust compiler can infer what type a variable is. This is like this is like automatic type inference, but when we are creating a class in C++ where which uses template like a vector, we have to specifically given whatever the type of the vector is going to be. But sometimes we can avoid this if like a size 10, but we can sometimes avoid giving this template argument if we tell what the thing is going to be. Here the compiler can detect that A is going to be a vector which is going to have 10 elements and each value is going to be an integer which is equal to 10. So we don't have to explicitly give here integer because the compiler can see this and the compiler knows this is an integer. So the compiler will do compiling, or we can say this to make like 0 initialized vector of 10 elements. There is a specific name for this thing: automatic template detection. C++ class template argument detection. Shit, yes. Class template argument detection. Class template argument detection. CTAD. Class template argument detection. Okay, yes. CTAD. That is the thing. Class template argument detection. So, okay. Type inference. This is kind of the same concept at a different, like smaller level. Yo, let's go. They are adding support for drivers to be written in Rust. That is cool. Drivers to be written in Rust. And the benefit that Rust provides is memory safety. And if the drivers are written in Rust, that, okay, I don't know why that would be like if we want to write drivers in Rust. I don't know enough to make an argument why they would be doing this. Not the whole thing. Okay, yes. What language do you do other C++ other than Rust? C++ I've been doing. And how about writing graphics which run on CPU without using OpenGL or such? I mean, I just right now don't know anything about graphics. Graphics run on CPU. Wait, so OpenGL cannot run without a GPU because I'm using a Mac and this has like two GPU cores, two or three GPU cores on M1, 7 to 8 GPU cores. So shit, OpenGL runs on GPUs. Uh, bro, I have to multiply. I have multiple interests. ML, LLD. What is LLD? Shit. And competitive programming. How to manage them all. Well, if you get fed up with one, go on to the next thing. Just don't be confused. Choose anything and move forward with that. Make progress, I guess. Watching from Nairobi. Yo, let's go. Kenya. Joshua Maybe. Hello. How easy is it to find a rest job for entry level job? I, I would have literally no idea. Sorry, I wouldn't know. I'm just learning Rust because it looks cool and I can flex on my friends that I can write in Rust in Vim. But alas, I don't have Linux, so that is bad. Nice, same. C++. Bruce done with CP and moved on to Rust for a few days. I moved from CP to web development. Like when you say moved, you are not doing any CP at all. That is kind of crazy. How did you gain your knowledge in C++? Yo, it was the book by Mr. Björn Stroustrup himself. This book, the C++ programming language, 4th edition, Björn Stroustrup, and the colors are inverted. Yes, the C++, and this is for C++ 11, but this is going to help you a lot. Yeah, this is pretty cool. And if not the whole book, then you can at least read this introductory material. And when you are reading this for the first time, if you are reading this, then this is going to be very dense. There is just so much information in these 5 chapters, a lot of information. So this will feel very, very overwhelming. Just go through with it. And after these, you can read these 3 STL chapters. Introductory summary just seems too much abstract. This chapter number 30 seems too much abstract. These 3 chapters you can read. That would be nice. And maybe the chapter on strings and IO streams. That would also be nice. Yes, what is LLD? Low level development shit. Okay, okay. Bros E is not working. Engine. Okay. I did it for a few years, but I cannot do multiple things at the same time. So I put it aside for a while. Okay. Well, okay, shit. So maybe it is just me. If I just do one thing the whole day, it doesn't work out. I feel burnout and yeah, it just doesn't scale. But if I'm doing 2 to 3 different things, then it works out pretty fine. And what is that color in? Yeah, that is this dark reader extension. Works on PDFs. That is crazy. Have you read the whole 4th edition? No, not the fourth, just the introductory part. And I don't even think because I don't need abstract mechanisms while I'm writing C++, while I'm solving competitive programming questions. So I didn't need all of this. Like but I did read about templates. That was nice. Yeah, I have only read about the things which were important, like, which I needed. This whole thing, concurrency and utilities, concurrency using mutexes was amazing. And yeah, all of these things, expressions and statements, but not like I know every word that is written there. Yeah, I forgot namespaces, and yeah, these parts, a few of these chapters, just the things that I needed. And here, type inference. Most of the time, Rust compiler can infer what a type of a variable is, so you don't have to write an explicit type annotation. Okay, throughout this tutorial, types are explicitly annotated in many places, but only for demonstrative purposes. Type inference can handle this for you most of the time. Okay, let explicit x is this. Implicit. Okay, this is implicit because implicit we are not telling that this is a integer 32-bit or that this is a float 64-bit. Can we have float 32-bit? I think we can. Okay, arithmetic. Let sum equals this. Okay, mutable variables. Okay, they are just saying mutable variable. This is a mutable variable and this is a immutable variable. But what is mutability and immutability? No idea. Okay, we can use plus equal to. That is nice. Now strings. Let's go. String. Okay, this symbol and symbol. This is just shouting reference. This symbol, because in C++ this is used for reference. This is just shouting reference. Okay, string literals. X is a string type and the string is hello world. Printing. Okay, yo, let's go. Println. And why do we use this thing? And what is this and? We use this 1.3 1. Okay, 1.3 is f. Okay, f was equal to 1.3 and here we are passing on f, so f will go here inside this thing and inside this thing we will have hello world. Okay, nice. A string help allocated, heap allocated string, help allocated, a string, a heap allocated string stored as. Okay, this doesn't seem very good. A string, a heap allocated string. Okay, stored as vector of 8 byte, 8-bit character representation like ASCII vector with valid UTF-8 sequence, which is not null terminated. Okay, okay, so we have two different things, and str and string here. Okay, this thing, shit. Okay, this is a string literal on the stack, and this is on the heap. Okay, okay, they are not explaining a lot of things like what is this and thing and why are we using this, and uh, I would need a little bit more information on mutability and immutability than just saying this is immutable and this is mutable. Bruh. Okay, let's go through this once, and then there is also one thing at the end, half hour to learn Rust. This is pretty cool. I think this is better than the thing we have been reading. But anyways, just because I have this in a Excalibur PPT, this thing here, we will have to go through this once at least. Okay, so this is the we are only just hypothesizing because they are not giving us a lot of information. This just says a string literal, and literals are on the shit. Literals are not even on the stack. Literals are a part of the binary. Literals are more like in the like static memory, I think. Yo, Harkirat has a yes, he does has a crash course on Rust. Okay, shit. The exclamation means print ln. It is a macro which will get turned to other code at compile time. And if I do not use exclamation at the end of print ln, will it still work? Or like, what is print exclamation here? It is a macro. What is a macro? We already have the base println function. What is the new thing, extra thing, which we get by using exclamation mark? And we increase the size, and which will get turned to other code at compile time. Okay, macro will get. So what do we get by this macro? Hello, Ski. Bro, I am new to programming and I am planning to learn C. Don't plan, just start learning. How do you think it takes to learn the basic? How long? It depends on how much you are putting in and with what mind you are getting into it. Right. So it depends on you. Completely, it is up to you. The Rust book is a lot better than this. Okay. Yeah, book next. Yes. Right now, this is just getting started with Rust in a few days. But when I'm like going all in with Rust, I will be using the book. And shit, next year we do have a new version of the book. Uh, third edition. We can pre-order it on Amazon. It is still not out. You can pre-order on Amazon. It says 2024 due to some reason, but yeah, it is going to be released next year. It is not there yet, right? Third edition. This looks raw. Yes, this is raw. They literally have a crab. It depends on how many hours you sit a day and how easy you learn. Yes. I think you have to sit at least 2 hours every day and don't stop. You go on. Yeah, they are in the binary. They are, yeah, literals. Literals are literally in the binary. Literals, literally in the binary. And string is a reference to a static portion of the dot text section of the binary. And I'm just amazed that I'm able to understand what you've written here. That is pretty cool. Wait, static portion of the dot text. I think the dot text and the static portion are different parts of the memory hierarchy. Memory layout, I think they are different. Text, initialized data. Okay, this whole thing is static. Okay, we call this whole thing is static because nothing changes here. Uninitialized data, BSS. BSS should BSS base symbol should BSS has a full form. I forgot. Static memory layout because this does not change, or at least the size of this thing does not change. Your code does not grow in size while the program is running. So yeah, that is static. And this has base symbol, base started symbol of dot bss section full form in the context. Block started by symbol, and by symbol I would suppose it means the name of the variable, because we don't have anything inside the variable, we just have the variable name. and these things are called static. Why static? I think we should be able to initialize these variables. If they are not initialized at compile time, they could be initialized later while the program is running. So the data in this thing can change. The static part comes not from the fact that the data is changing or not changing, but from the fact that the size of this static part is not changing. We are not going to say give me more of the static memory or take away some of the static memory, but that can happen on the heap or the stack. Stack can grow, heap can grow, and we have a website, Stack Overflow. Okay, that seems nice. For all people, you have to pin the message of your Discord link at the live chat saying that the resource for programming. Bro, shit. Shit, you cannot do that. You cannot send links. Wait, where is the thing? It is in the description of the video. Why are you why are you learning Rust by any chance? Because I don't know Rust and Rust seems cool. I mean, like, yes, that is reason enough, I guess. I mean, nothing made me learn Rust, just I don't know Rust and I wanted to take a little break from competitive programming, so why not Rust? That seems good enough a choice. Yeah, this is the thing. Discord. Shit, this is peak self-promotion. Join my Discord. Peak self-promotion. Pin in the live chat. Okay, let me pin the message. Bro is teaching me how to do things. That is nice. Thank you. Okay, it stays at the top. That is nice. Rather than staying at the bottom. Do you student? Yes, I am a student. All right. Hello, mate. Billy. Billy the Butcher from Australia. Aussie. Are you taking a break from CP? Yeah, for a few days. This is not first video for learning Rust, right? For learning Rust, yes, this is the first video. Like, yeah, I only have heard people talk about Rust online, but yeah, this is the first time. Literally, I'm getting into Rust, so that is nice. And shit, I'm yapping a lot. Stored as a vector, and I suppose VEC just means vector. And this is very easy to learn Rust after getting better with CP, with C++. So yeah, that is also helping a lot. You have never seen any live streams. You are a streamer, bro. Lol. Never seen any live streams. You? Nope. I don't. I have watched Eric those live streams. They are nice. Yep. Yes, mate. I'm using Mac, which is like a crime because I use Vim. I should be using Linux. I don't have a uh, x86 processor, so I cannot use Linux. My bad. But yeah, I will get a Intel processor or AMD, and then I will run Linux. That would be nice. Okay. This thing is a literal, and this gets stored in the static section. Okay. This is how we format a string, and then string when we use like capital S, this goes on to the heap, and to string. Shit, this is voodoo magic. What is going on here? Uh, so we are calling a method on this thing. So this thing is a object, but if this is a object, how do we have this object on this as a literal object? Okay, I guess we should go with this article. This would make more sense. Graydon Hoare. Yeah, Graydon Hoare is the person who made Rust. Okay, we will be going with this article instead of with this because this just seems a bit too abstract. Things are not in any particular order. Vectors and arrays like this. Okay, let's go with this one. In order to increase fluency in a programming language, one has to read a lot of it. But how can you read a lot of it if you don't know what it means? That is a very genuine question. In this article, instead of focusing on one or two concepts, I will try to go through as many Rust snippets as I can and explain what the keywords and symbols they contain mean. That is amazing. Ready? Go. Let's go. Wait, let's Rust not go. This also I can replace pinned message. Yeah, I can just yep, pin message is here. Well, I can yeah replace. Yep, this is the new pin message. Variable bindings. The let keyword. This is much better than the other learn X environments. Let introduces a variable binding. Okay, a variable binding and binding just means a variable. And if binding means a variable, why are we calling it variable binding? Variable. Programming language. Yes. Let's go to Reddit. The Google snippet I got when I searched. Okay, so bro is coming on to Reddit and saying what he got when searching on Google. Uh, Assignment versus binding was binding is used to create a new variable within the current context, while assignment can only change the value of a given variable. Okay, okay, binding in the sense of a verb, not a noun. Okay, so these two are verbs, not nouns. I think it is okay for you to treat assignment and binding. Binding is simply the act of giving another name to a data structure. Named data structure, also known as variables, is giving a name. Okay, we are binding some thing in the memory with a name. And what the thing in the memory is referred to as a variable. And the act of like let's say this is a variable something on in the memory integer or something. Integers don't have to be on the memory. By on the memory I mean heap or stack or static memory, anything just on the memory. So we have something and when we give it a name like ABC anything, this act is called binding. We are binding this thing with this thing. Okay, that is the definition with which we are going to go forward. Okay, let x declare x and x equals 42, assign 42 to x. This can also be written in as a single line like this. Okay. Okay, now type annotation. You can specify the variables type explicitly with this type annotation. Makes sense? That is type annotation. Let x of type 32 and x equals 42. 42. Why 42? There is a very specific reason we are going with 42. Also, I feel the more languages you learn, more confusing it gets. Or if you do understand like the basic, learning assembly was a very good thing, I would say. Learning assembly was a very good thing. And yeah, so when you are just finding out what these things would result in while when you compile this thing, and if you understand that, then it is not confusing anymore. It makes sense when you know what is going to happen when you compile your program. Like they are all combination of different languages. Combination. Okay, I would say if someone does not understand the low level things, then for them it is more of that. Look at this. Rust uses let. Let comes from JavaScript. So Rust has borrowed the syntax from JavaScript. But if you do understand the low level things, the picking features from other language is not at the syntax layer. It is lower than that. It is more at what is this thing going to convert into. So Rust does not uses a garbage collector, and that is a feature, or maybe yeah, feature of C and C++. So yeah, learn low level things and you will have more idea of what is going on. Yo, and how does it work in JavaScript? Do you mean what? It is a interpreted language and very slow language. It is just a culmination of a lot of things coming together. I feel like learning more languages, the less confusing it gets. Yes, it gets less confusing because you are able to understand general concepts which are there, like the paradigms, object oriented and things. More perspectives you understand. Yes, it is at the semantic layer. If people do not understand the low level details, then they find the similarities at the semantic layer. Wait, semantic. I'm reading semantic as syntactic, and are they the same thing? Semantic and syntax of a language. Like syntax and semantics are not same. Shit. Okay. What is semantics? Semantics is a more weighted term, I think. Semantics meaning the study of meanings of words and phrases. Shit. Okay. That is more weighty. The meaning of two words and phrases. Semantics. Okay, so what you have written, what it translates into. ELI 5. Explain like I'm 5. Semantics are what gives the syntax of a programming language meaning. So the syntax defines what the text of the language looks like. Semantics gives that text a computational meaning. This can often be rigorous formal definition. Okay, okay, okay. That much definition, I think, is enough. Syntax is how a language looks like, or like, okay, and semantics is what certain keywords stand for, as in the meaning. Semantic, you are expressing. Syntax, expressing how you express it. Okay, okay, okay. You are expressing and how you express it. So, would a concept like object-oriented programming, would it be a semantic thing? And then writing the word like this in C++, class, and then my calls. This thing is syntax, but the whole concept that you have classes, that is semantics. Okay, that is nice. That is nice. So paradigm is just one layer of semantics, and okay, that is nice. That is nice. Syntax means how it looks, and semantics means what it means. That makes sense. Okay, that is cool. Object-oriented programming is semantics, like that concept of object-orientedness. And by the way, there is a talk by Casey Muratari. object-oriented programming. He gave a talk, the big oops anatomy of 35-year mistake. In this, tells us why object-oriented programming was a mistake. Yeah, he goes into a lot of things. I have not watched the whole thing, but yeah, he read a lot of things for preparing for this talk. This is pretty cool. Pretty cool. Casey Muratori is pretty cool. Okay. Could you think of You could think of paradigm as a way of approaching the semantics of a language. Yo, Casey Muratori. Yo, he's amazing. He's pretty good. He has been programming since 1995. And yeah, he once said that whenever he goes to a hardware talk on hardware, he rarely sees anything new because he knows everything. Yes, he does. He does. He does literally know a lot of things. He's like Super Saiyan, or like some super crazy, powerful anime character. And okay, this is interesting. How you approach the semantics of a language. Shit, shit. On the top, we have paradigms, or like higher, not on the specific exact top. I think that is the correct spelling. That might not be DIGM shit. That is the correct spelling. Paradigms. Then we have semantics and syntax. And syntax. Key paradigm guides semantics and semantics guide syntax. Okay, nice. Paradigms could be object oriented, functional, or whatever the rest of the things are, and they guide how the semantics should be. And semantics, like what are the concepts our programming language is going to have, they define the syntax. Like in Rust we just saw that we have to use mutable. In Rust we have the concept or semantic that there are going to be two types of variables, mutable variables and immutable. And this thing bring forth brings forth or brought forth the syntax of using the word mut before a variable name. Okay, we can go with that. That looks nice. So, like a category of semantics, that is, OO has object-oriented, has many semantic structures bound together by central guiding philosophy. Yo, let's go. Yes, you put it much better than me. Okay, thank you. Yeah, this makes sense. This makes sense. This makes sense. Okay, type annotation. You can specify the variables type explicitly with a colon, not a semicolon. This is a colon. That is pretty cool. That is a type annotation. This thing is a type annotation when we are explicitly telling the type. There is I8, 8-bit integer, 16-bit integer, 32-bit integer, 64, 128. Let's go bonkers. And I 128. 128 is too much. We can use 50 digits. We can use 36 digits, I think. That should be enough. And add 5 to this thing. This. And I suppose, shit, we have to change the function definition here. Second variable, we are putting x as the first variable, 128. And the return type should also be 120, 128. 64, 128. Okay, this should work. Hopefully, this should work. Rest C. Hello. Okay, this doesn't. This doesn't work. Expected one to. Okay, I thought as in C++, this Y is 132-bit type byte. And this Y has 4 bytes of memory, that is 32 bits. And if we are adding this to a higher data structure, then Y would automatically get converted. But that is not happening. Okay, so we have to change Y also. Y I128. Shit, I think this thing should also give us error because we are not telling that 5 is 128 bits, or maybe this is too obvious and the compiler will do this for us. Let's see. Let's see. Hello. Okay, it works. It works. And yes, it does seem to be working. 33 plus 42 is 75. That is nice. That does work. That is nice. So, Rust for CP? No, just Rust for learning Rust. Called dot into on Y. Okay, dot into. If we do dot into, we can change Y. Okay, this doesn't like implicit coercion. Okay, if I just an integer. Okay, 5 is just an integer, but it is like it's still being added to X without any problem. You are saying we can use dot into I128. Is this the thing? Not G++. Rest C. Hello. Okay. No. Hello. Okay, still there is some error. Dot in just dot into and nothing inside makes sense. The compiler treats it as whatever integer type you need. Okay, that is nice. I don't know if into will work, but that is a way to convert. And compiler is telling me unexpected argument. This is pretty nice that the compiler tells where the error is, not a value. Okay, we have to provide some value here, and that is error number 1, error number 2, and help. We have a help, remove the extra argument, and this thing should work. And yes, the size is a bit too much. I still there. Yeah, let's be normal. I128 and remove into. We will go step by step using this article. This has to be 128. And now, yep, everyone is happy now. Yo, this is pretty cool. We can use 128-bit integers. Yo, Rust is cool. Rust is cool. Yes, this ain't an LSP, bro. Yes, not today. Not today. We are doing Rust. Yes, they are very helpful. And shit, I think I've seen the guy who has written. Wait, shit. Was a person on the Primogen's channel, and he has not written the compiler, but he has written Rust Analyzer, the LSP for Rust. And yes, we are not doing LSP right now. There is a LSP docs by Microsoft. Whenever we will be doing LSP, we will be using this specifications, and yeah, LSP is divided into different parts. And sorry for the light thing. Yes, we have, this is the base protocol. It has a header part, then content part. Yeah, that is just it. And we will just implement this. This will be pretty cool. Whenever we do this, that would be cool. ATP, just learn it later because it gets messy. Yes, yeah, step by step. I think 128, I-128, I know has fewer qual. What is qual? Things. Just is pog jams. Implement 10,000 lines of tutorial shit. No, 10,000 lines of tutorial. What is 10,000 lines? Shit. And the specification for LSP was too big. It was too big. Okay, we also have unsigned option. If you use U, that is nice. This can also be written as a single line. That is nice. Now, uninitialized variables. If you declare a name and initialize it later, the compiler will prevent you from using it before it is initialized. Borrow of possibly uninitialized variable. And also here, while writing the language, I'm not getting any errors because the Rust analyzer is not working. See, no Rust analyzer working. Brew install Rust analyzer. Okay, it is there. Oh, it is not there. Rust analyzer. Okay, it is downloading. That is nice. Fewer quality of life things. So it doesn't have a lot of support because it is too big. Microsoft LSP guideline has 10,000 lines. Yeah, yeah, we will get there. We will get there. We will get there in one stream. Have you set it up in your new vim config? Yes, I was trying to do that, but LSPs, LSP config, and no, shit, it is not there. And it's when I was trying to do this, when I was learning like how to do things in new vim, uh, this Rust analyzer was not working because it needs a like root folder, root directory, which it maintains as the root and works from there. But when you are writing in a like simple normal file without project initialized, then Rust analyzer does. Only then Rust analyzer does not work if you do not have a project initialized. What is this? How you do? I'm amazing. What is the language? What is this language? This is Rust, one of the best languages. How do one even read C++ documentation? I tried reading for ISO, okay, but after some lines it got fucked up. I couldn't even figure out the types. Okay, C++ documentation. Reading the literal documentation is pretty hard. Let's say lower bound C++. If you go to, there are multiple things. If you go to CPP reference, then this is very archaic. This is very hard to interpret. But if you like be patient, then you will be able to understand it. So this thing has multiple things. This is like uh, overloaded. Lower bound returns a forward iterator, takes in forward iterator as last forward iterator, and a constant value type. or it can act as a constant expression, or yeah, these are the just different things. It can also take a compare function, normal compare function, and forward iterate compare function with constant expression. And this is a bit cryptic. Like, yeah, this is a bit cryptic, but if you go to C++, this one is a bit more human readable. Return iterator to lower bound returns an iterator pointing to the first element in the range which does not compare less than value. Yeah, so this website is much better in terms of like readability, but I think this is not up to date because here we have things from C++26 which isn't even supposed to be out. We are still in the year 25, so this one isn't even supposed to be out. This is already here, and here, what is the, how do we see the version? C++ 11, and this is old. This is old, like Mr. Gary Oldman. Yeah, this is old. All of these just say C++ 11. Let's go to something. Shit. Yeah, this is old, but this is more readable than this lower bound. Then yeah, then CPP reference. So it is up to you. You either go to c++.com or CPP reference. Yo, do you use a package manager? I have always used Lysium. I do use Lysium for installing packages, but for installing and running LSPs, I do not use Mason. I do that manually so that I do not forget how it works. Rust Analyzer will work when you start using Cargo, then Rust build tools and package manager. So let's set up the Rust Analyzer. Bro, this is sabotage because you have read the Linux Bible. So this is sabotage. You cannot say this to other people. All right. So just continue the tutorial. Yes, yes, yes. Try reading for easy. Some are easy, but if the next documentation for Next.js is amazing. No, no, I admit defeat in that thing because learn X in Y minutes is just, it was just getting too abstract. It was not treating the person reading the article as if they might not know what they are reading about. Learn X in Y minutes was like, yeah, this is how things sit. This is what it is, why it is, or whatever. Yeah, it was not explaining things correctly. Yes, let's begin with the tutorial. Before that, vim.lsp or config rest analyzer, and this should just work. Okay, and cargo. How do you initialize a project? Init. Cargo init. Okay, it even initialized uh like Git repository. That is nice. hello.rs is still not running. Failed to run Rust analyzer. I think the syntax has to be different. Let us speak of config Rust analyzer. How do we start Rust analyzer? LSP config Okay, it is underscore, not hyphen. Underscore. Just now it should work. Or maybe not. Shit. Settings equals Rust analyzer. Diagnostic enable false. No, we want enable to be true. Copy paste, of course. And now this should work. Okay, no, it doesn't work. Yes, it doesn't work because diagnostics are false. Okay, and list info, this isn't even running. Okay, that is crazy. Vim LSP enable. We have to do this. Vim LSP enable. Wait, so how are the other things working? We are not using LSP enable for them. Wait, I don't even have C++ here because I enable the C++ LSP on my own manually. Okay. Vim dot LSP dot. Wait, this would just enable Rust analyzer no matter where I am. Okay, okay, Rust analyzer seems to be working. Enable configurations. Root directory is correct, seems to be correct. Command is diagnostics, true. Okay, but this is not giving us any errors. It is shit. Okay, okay. Now everything is okay. This file is not included in crates, so Rust Analyzer cannot offer IDE services. Okay. And so we go to src and main.rs. Here, let's run the LSP. LSP start. This is not giving us error. This is just giving us a line here that there is something wrong. Okay. Okay. Print ln. Okay. And look at this. We are even getting errors now. Hello world. We are not getting error because okay, my working. Okay, this is enough. This is good enough. Pure hell. True enough. A fresher will destroy his passion for coding if he reads documentation. Yeah, a fresher would. Want my configuration for Rust? NVChat beast config. NVChat, what is NVChat? A person. Goated. True enough for beginners. Videos are good, especially. Yes. Python, Rust, etc. have pretty good and eye pleasing documentation. Yes, Rust documentation is amazing in like dark theme mode. But yeah, we just want a kind of refresher. Okay, just let's focus on this. If you declare a name and initialize it later, compiler will prevent us. And now our LSP is working, kind of. So that is good enough. Will prevent you from using it before it is initialized. Okay, you will get error if you use a variable before initializing it. However, doing this is completely fine. Okay, we declare a variable, initialize it, and use it. And throwing values away. The underscore is a special name, or rather a lack of name. It basically means to throw away something. So this does nothing. This calls get nothing. Okay, this just calls this function and throws away the value, whatever it is. Yeah, throws away the value what we get, that we get. Names that start with an underscore are regular names. It is just that the compiler won't warn about them being unused. Okay, names that start with an underscore are regular names. It is just that the compiler won't warn about them being unused. Okay, unused. Let underscore y equals 10. We are not getting any error here. Underscore y equals. Okay, now we are not getting any error, but now we should be getting error. Okay, LSP is messing up. Now we are getting error. Now we should not be getting error, and we are not getting any error. So that is nice. Shadow, and yes, I will have to fix up the LSP, whatever the problem is with it. We may use underscore x eventually, but our code is a work in progress, and we just wanted to get rid of a compiler warning for now. Okay, compiler will give us the warning. Separate bindings with the same name can be introduced. Okay, that is crazy. That is crazy. You can shadow a variable binding. Let's do print x. We will print number, and let's give x. X is not defined. Let's say x equals 10. And if you were to do x plus equals 10 cannot reassign a mutable variable. But if we say that x is a new variable, then what? Then it is nice. Then no problem. And we are also using the earlier x. That is nice. Okay. Okay. We cannot change the value of a variable, but we can create another variable with the same name, or another binding with the same name. And that does the work of kind of changing the variable. Okay, that makes sense. It sets up Rust. You could also try Rust is Asian Newim, which contains a bunch of Rust tools like LSP. Okay, at this point, bro is just messing up his config. Bro, yes, okay. It just sets a Rust analyzer for you. Okay, I will use that. I'll use that. Isn't the shadow binding feature in all languages? What is okay? Shadow binding is a you can shadow a variable binding. Shadow binding in programming. Variable shadowing. In computer programming, variable shadowing occurs when a variable declared within a certain scope, decision block, method, or in a class has the same name as a variable declared in an outside scope at the level of identifiers. Okay, so okay, this makes more sense. The new variable which you're creating is in a like smaller scope, which is within the larger scope in which the original variable exists at the level of identifiers names rather than variables. This is also known as name masking. So we do have in like C++, blank D, int x equals, let's say, 10. And if we create another scope, we can say int x equals 10. And these two are different. This is normal shadowing, the thing which is like here. We have a variable in the outer scope, and inside that scope, I should not use mouse. We have a variable with the same name. Can we do this? Okay, we can do this. We are not getting any errors. This is cool. Shit. We are getting the here value of the outside thing. But if we were to remove this scope, this is error, redefinition. But in Rust, there is no error. We can do this in the same scope. So that is nice. Yep. Local and global. Hee Learning to learn to think deep. Local and global, not local and global. Yeah, relatively higher or lower scopes. Okay, now this. Okay, shadow makes sense. Shadow. And using x after that line only refers to the second x. Although the first x still exists, it will be dropped when going out of the scope. You can no longer refer to it. Tuples. Rust has tuples, which you can think of as a fixed length collection of values of different types. Let pair, yeah, fixed length makes sense. Pair dot zero to get the first thing. Okay, this syntax is okay. This syntax is nice. This is nice syntax. Dot with a number. That is nice. First time seeing this. If we really wanted to annotate the type of pair, we would write this. Okay, okay, okay. That is how we can tell what types in a tuple are going to be. And destructuring tuples. Tuples can be destructured when doing an assignment, which means they are broken down into their individual fields, like this. This will get some character, and this will get some integer. Now, some char is a and some integer is 17. This is especially useful when a function returns a tuple. Splice, split at middle, this will return two things. For left thing will go here, right thing will go here. Of course, when destructuring a tuple, this can be used to throw away parts of it. Okay, let's use our tuple then. Let TP with type annotation, literal type annotation. We'll say we have a, okay, we don't know about strings, so integer 32 and integer 128 values, which are 37 and a very big number. Very, very big. That does work. Okay, and x does not exist, makes sense. Let's use x comma y equals tp. We do still get the error. Unused variable y. Okay, so okay. sum this plus this equals this, and we cannot add a 32-bit integer with a bigger one. So this and then x plus y. This should work. Rest C main.rs flash out, and it does work. That is nice. Rest source main.rs. Okay, that does work. So we know about tuples and how to destructure tuples. Now statements. The semicolon marks the end of a statement, which means the statements can span multiple lines. Okay. Vector. Okay, this syntax is amazing. This thing. We will go over what those actually mean later. That is nice to know. Function fn declares a function fn. Here, this thing is much better than learn x in y minutes. No, vectors are different. Vectors are, first of all, variable length, and everything in a vector has the same data type. Tuples are fixed length, and every element can have their own type. Like this. Here we have a character and an integer, and the total size is fixed. We cannot add new things to this tuple. This is more like a structure. Yeah, this is more like a structure. And that is, yeah, it is different from variable, from vectors. A function. And yes, when I posted that poll yesterday, I thought, yeah, I was excited about other things too. Writing an LSP 10,000 lines would be amazing, would have been pretty cool. I think vectors have two different types, type, integer, no, that pairs can have two different types, but a vector, and you do mean vector in C++, I suppose. In C++, vectors have to have the same data type, the element. Okay, this thing, types. The template does not take multiple things. Uh, hello.cpp. If you mean something like lsp start lang int main and include bits std c++ or h. We cannot have something like this. Yeah, because this doesn't work. Now it is okay. We cannot give two types if that is what you meant. But we can have a pair which can have different types. Pair, P-A-I-R. Yeah, we can have this. And here also, every element in the vector is of type pair. And each pair has two things, an integer and a character. Yeah, so that is nice. My bad. And there is a function. Here is a void function which does not return anything. Hello. And here is a function that returns a 32-bit integer. And this syntax for returning things is amazing. Yeah, this is pretty cool. And I suppose if we were to use a semicolon at the end, this thing would not get returned. And if we do use a semicolon, we would have to use the explicit word return. The arrow indicates the return type of a function. Fn returner, and this takes in nothing but returns I32. And why is the LSP not LSPing? Because LSP is not there. LSP start. Okay. I32. Let's say 5. And is never used. We can use this. Let x equals x plus returner function. X is a big value. Okay. How about now? Now it is okay. Now it is okay. And we were to add a semicolon. Okay, this is wrong. But if we add the return word, it works. LSP is very slow. LSP is very slow. LSP is very slow here. Wait, why do we not have any error here? We were getting error here just a moment ago. Okay, we are getting error. Okay, if we do not want to use the semicolon, we cannot use the return word. But if we do want to use the semicolon, we have to use the return word. That makes sense. Bro, what confusement. Blocks. Here is a function that returns a 32-bit integer. Yeah, cool, nice. Blocks, a pair of brackets declares a block which has its own scope, just like in C++. This thing has its own scope. Okay, this is a string. We haven't worked with strings. It would be nice to see how strings work. Okay, blocks are expressions, and println print into this thing in and into this thing out. Okay, blocks are expression. Blocks are also expressions, which mean they evaluate to a value. Shit, okay, that makes sense. Blocks are expressions and they evaluate to a value. So if we have, let a equals 37, and this works underscore, so that we do not get any errors. But if I were to add a semicolon here, this still seems to be working. That is nice. And if I write the return word here, mismatch types. Mismatch type expected that thing. Okay, why do we have this here? No, this is not working. Mismatched types. What? I'm not using a anywhere else. Expected brackets because of default return type, mismatched type. Expected this, found integer, unreachable. Yes, we didn't have spacing. That was the mistake. There's something wrong. Okay, now it is working. Shit, it was literally space. If I remove the space, okay, it was just hallucinating, I guess. The LSP was just hallucinating at that moment. Now it is working. LSP is slow. Yes, this modern programming languages issues. Uh, I would have to configure it. Think of it like this. Rust automatically returns the final expression from a block. And if you end the last line of a function with this, then the actual last line of the function is the nothing. Ah, okay. So it returns the final expression. That makes sense. Here they said that the whole block is expression, or that is how I interpreted this. Interpreted or compiled blocks. Okay, shit. Okay, this last line tail is what the block will evaluate to. Okay, and that is why this syntax works, because this thing is the last line of this block and this gets returned. Okay, that is pretty insightful. And if we do use a semicolon, then there is literally nothing after it. So okay, rest is just weird. Expressions. Okay, if you shit, I'm trying to think of a movie reference. I guess you can use this from X-Men. If you don't understand them, kill them. That is what you're doing here. If you don't understand them, kill them. Expressions are the best returns from a function, not a block. Okay, thank you for that. This is the nothing type. Okay, it represents the lack of a return type. The nothing type. Oh, so if I were to do let C equals C is nothing. LSP. Yeah, this seems to be fine. Also, Rust analyzer often doesn't update till you save. Shit. Rust analyzer is okay. Maybe this is not a problem with the Rust analyzer, but I have not configured this correctly. The person who made the Rust analyzer came onto the primary Rust developer. Wait, not this one. Um, the stand-up. This guy. Zig and Rust in production. This guy. Matt Clad. He is the one who made the Rust analyzer. That is nice. Okay, so I have to save the file to see the things. I never touch Rust because the documentation looks good. But the documentation looks good. Yes, documentation does look very good for Rust. The official Rust documentation. Learn Rust. This one. Read the book. This looks very good. Like, look at this. This is very beautiful. You can go to the next page from here, the slice type, and we also have projects here. I think the last project is building multi-threaded web server. That is nice. That is nice. And onto this thing. Inside a block, there can be multiple statements, and the last statement is the thing that is evaluated and returned from a block. So 42 and this A should be equal to 37. And if we do A comma C, or more like. C is nothing. Yeah, C is nothing. C is nothing. So 42. Hello.cpp rust C main rust 39. Yes, that is the correct answer. Implicit return. Explicit, implicit. That is why omitting the semicolon at the end of a function. That's why, yes, omitting the semicolon at the end of a function is the same as returning. These two things are equivalent. This is returned. Everything is an expression. If conditionals are also expressions. Shit. So if what is the syntax? If feeling lucky, if A equals, is that how we see equals 42, then return 37, else return 42. Shit, that does work. That does work. Shit. Okay. Shit, that is cool. That is cool. Just C main.rs /out. Yep. If we chain the order here, just C main.rs out.out. And yep, A is now 42 and B is now 37. Okay, so everything is a expression. And this is crazy. Everything is the expression. Okay, everything is the expression. That is nicely expressed. A match is also expression. Okay, I don't know match. Match is like enum. A match is also an expression. Here, feeling lucky is, I guess, match is like an enum. And why is this like sponsored by Google, the feeling lucky button? I'm feeling lucky. What does this even do? Doodles are celebrations of culture, places. So this just brings up doodle. Okay. Okay, everything is a expression. I have heard this thing before somewhere. Everything is an expression. Shit, everything is an expression. Expression or something else. Shit, yes, in Linux, everything is a file. In Linux, everything is a file. Yeah, in Linux, everything is a file. So to explain the main function implicitly, okay, the main function implicitly returns empty type because there is no return type. We have main, okay, 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 because there is no return type. When you typed return 37, you were returning an integer and not this empty type. Okay, return 37 inside the block which was defining A. Yeah. Being able to use an if as a ternary solves the usual unreadability issue with the ternary operators. But ternary operators are also very concise. Match like switch case. You can match on an enum. We can, what is this thing even doing? Match feeling lucky if Okay, this is kind of like if, okay, shit, okay. This is like a switch, okay. If true, then return this. If false, then return this. And if that is the case, why do we have a extra comma here? You can match on any next mention. Yes, of course, next mention. It is like always there at the back of the mind. If true, return 6. False, return 4. That makes sense. And yes, this comma is still like crazy. Why do we have a comma? Okay, but this is, yeah, this syntax is not very concise. A ternary operator would be more concise. Everything is a file in Linux. Dots are typically used to access values of a field. So dot 0 get the first thing, dot 1 get the second thing. Let Amos get some structure. Amos must mean something. This is faster than line. Okay, this might be an internal joke for them. Or call a method on a value. Let Nick equal to faster than line, then length. Or call a method on a value. So we use dots for calling method and field accessing. Okay. For accessing members, we use a dot. And for calling methods, we use a dot. Normal. This is normal. But this is kind of not normal because we are not using square brackets here. That is a bit unnormal. The double colon, this thing is similar, but it operates on namespaces. Okay, this namespaces was taken from C++. I think we can say that. Comma just after the arms. Just come after match arms. What is arms? Match arms. So comma tells that this match has ended. I think like a break statement in normal switch. Okay, this is their internal joke. Modules use this on namespaces. In this example, std is a crate, a library. Okay, a crate, a library is called a crate. CMP is a module inside a library, a source file. CMP. Okay, and min is a function in that source file. Okay, okay. Library has modules, modules are files, files have functions, and okay. Standard is a library. In that library, we have a module called CMP compare, and that source file module has a function called min, which returns the number least. Okay, use, and that is why we use this use syntax. In C++, we have using this, using namespace standard, but okay, here we have this. Okay, within use directives, curly brackets have another meaning. They are globs. Okay, okay, that is a bit too much information. Commas after arms. Watching learn Rust makes me want to learn C, but I'm scared I don't have enough brain cells. Bro, C is not that difficult. You can use the like goated C++ book, the C programming language by KNR, like Brian Kernighan and Dennis Ritchie. We can go with this, the ANSI version. You can even order this. This is like not very expensive, or at least for not for you. This is not very expensive. You can just order this book, and this is not even very long. And yeah, this is a very good book. You can read this for C. Arms are branches of a match. Okay. like Milky Way galaxy. We are on the outer arm of Milky Way. It's like a break. Okay, commas act like a break. Nope, it is not that hard. Make a compile. Learning C is different than making a compiler. Learning C is simple. C is like literally, C is very straightforward. There is nothing magical going on. No garbage collection, nothing. The C is just a bit abstracted version of assembly language. There is nothing special going on behind C. So you can learn C. C is, yeah, cool enough. Straightforward, not easy. Shit, that is very philosophical. C is straightforward, not easy. Shit. Okay, what is the distinction between the two words? Easy is something you can just do, but it might not be straightforward. Shit, like riding a bicycle is easy. You can do it, but it is not straightforward in the sense how do you explain how to ride a bicycle to someone else? It is not very straightforward, but it is easy. Like Python. Python is easy, but not straightforward. Hmm. Hmm. Python is easy. Yes, yes, we can say that. Python is easy. It is like literally English, but it is not straightforward in the sense what is going on under the hood. We don't know. There is just too many layers. Garbage collection, everything, allocation, deallocation, we don't know. And it's like mystery. Okay, back to this. Okay, we can use dot to access methods first of all, and to access elements inside a tuple or something. And then we can use this modules. When we want to use modules specifically, we can use double semicolons, library, module, and function inside a module. That is nice. I didn't know this thing, this part, this hierarchy. That is nice. Use, we can use the use so that we don't have to use this. Okay. Namespaces within use directive, within use directives. Okay, what is directives? This is the first time this is appearing. Use directives can be used to bring in scope names from other namespaces. Okay, directives is just like shit, one thing we have in assembly at the top, the things that we have, like text directive, and which tells whatever comes next has to go in the text section, or static directive which tells whatever comes next will go in the static section, kind of like that. Directive which change how we are writing code. I guess that is what directives is. Within use directives, curly brackets have another meaning. Within use directives, okay, they are globs. If you want to import both min and max, we can do any of these. Okay, we can bring both of them explicitly, or we can say in the standard library, in the CMP module, compare module, bring these two things, or this. Okay, that is nice. Or a wildcard which says bring everything. This is like a like regular expression thing. Okay, can we do some experiments with this, with this section? Yeah, yeah. Let's use a module. Let's use this module because we don't know any other module other than compare. Python is easy, but too much under the hood. Yes, there's just too much. C is the lowest layer of high-level languages, same as define in C or C++ maybe. Yes, define a directive. Shit, yes, define is a directive. Yes, shit, yes. Define, and macro is something else. Macro is like writing. short form for a code which will be expanded by the pre-compiler. Okay, let's use this. Um, this okay, LSP is working now. Pretty cool. std. In the compare, what do we have? We have all of these things: min, max, min by, and we like literally have all the definitions right there. It's cool. Core CMP max by returns the maximum of two values with respect to the specified comparison function. Shit, this is nice. Max by, this is the function that we are going to give, and they also have an example. Shit, this is too cool. This is too good. This is too good. In like while writing the language, I don't have to go to some other website. Everything is here. I even have examples. That is nice. X dot abs get absolute value of x, compare, and y. Okay, okay, that is too much syntax. That is a bit too much. Maximum of 10 and 37. We not int let. Okay, C was already there. Rest C main.rx dot slash out, and it does work. That is cool. That is cool. Okay. And yes, yes, a few other things. Use std. It's semicolon. Yeah, semicolon. Now we don't have to use this. This just work. And if we use till compare, we don't have to do this. Okay, we have imported the compare thing, but we haven't imported everything inside compare. Unused import. Shit, why? And it is unused if you wanted to. Max failed to resolve use of unresolved module or unlinked crate compare. If you wanted to use a crate named CMP, use cargo add CMP. Wait. Okay, shit, yes. Save the file. Yes, you did say save the file. Macros mean yes. Yeah, cool. Rust has great documentation, partially because of built-in documentation tooling. Okay, Rust has built-in documentation tooling. Always save the file. Yes, I will remember that to save the file. Rust has great documentation partly because of built-in this built-in documentation. Is it necessary to write the type like after int is we can infer the type. If the type is inferable, then it is cool. We don't have to explicitly write the type. There was type inference, type annotation. It should, there is not no type inference. Here, we don't have to explicitly write the type. So that is nice. Implicit return, everything is an expression, modules. Okay, cool. Now it works. Max, min, save the file, save the file. Wait, min is not being used. Okay. And let A equals min C A. Now it is being used. Okay. Always save the file. Yes. There are namespaces too. Yes, you mentioned that earlier. Types are namespaces too. Types are namespaces too. Not that there are namespaces. Types are namespaces too, and methods can be called as regular functions. Types are namespaces too, and methods. Types are namespaces too. Okay, so shit, this makes sense. Does it? Because REST is not object oriented. Incorporates some features commonly associated with object-oriented programming, but it is not strictly an object-oriented programming language like Java or C++. Struct, enums, encapsulation, polymorphism. Okay, REST does not have objects. So that is why when we are calling a function here, we are calling this a namespace, and not a method which is being called on an object, which it, which it would be referred to if you were in C++. And that is shit, that is just a different way of thinking. Okay, that is why I guess you should learn different languages. Rust is not object oriented. So okay, now I have few questions. Okay, let's first go through this. Uh, these namespaces and methods can be called as regular functions. Okay, methods can. So, what would a method mean in context of a non-object oriented language? And str is a type. Shit. Okay, str is a type, and here we are calling length function on this type. Okay, okay. So here is what I think. In object-oriented language, when we define a class, it has methods with that class, right? A class has methods associated with it. And when we create an instance of that class, an object, then we can call these methods on this object. Okay, so now the question would be, does each object get a copy of these methods? Do objects get copies of methods, or whenever we call a method, are they being, whenever we call a method on an object of some class, are they referring, like, is there a like central truth for methods, or each object gets their own methods? I don't think, okay, this would be kind of stupid or and inefficient if each object got their own methods, because that would just, if you have a lot of objects, and by meaning and by saying objects have their own methods, I mean they have whatever the code, the binary representation, or the definition for a method is, they have their own local copy of that definition. That would just fill up your literal code, your binary, with a lot of repeated code. I guess instead of, yeah, this just means, um, do they have a copy or do they have a reference? It is the main question. Do they have a copy or do they have a reference? In object-oriented programming. And we can translate this language into something like Rust. In Rust, we have namespaces. Namespaces where which has different namespaces have different things like files, modules, and these modules might have functions. And okay, these modules might have functions, and we are saying types also are namespaces in Rust. Types are also namespaces, and namespaces have functions. Thus, types have functions. So types also have functions. And whenever we have a instance of a type, a variable for a type, and when we are calling a method on this type, this variable is a namespace, and that this variable is a namespace. Types are namespaces, and when we are calling method, this for sure should have a reference to all the functions which are defined for the type that this variable is of. So if integer, if we have a variable, if we have a variable of type integer, that variable should have, if we have a variable, let's say x, and we have a type called integer. Integer is a namespace. It has a bunch of methods. I don't know what the methods are, maybe to string or something, to str something method. And whenever we are calling dot to str method on our variable, which is of a type, we are calling this function, which is in the int namespace. I think that makes sense. Always save the file. Yes. Methods are syntactic sugar largely. Rest methods are similar to Lua methods. Okay, methods are syntactic sugars largely syntactic sugar. Okay, okay. Rest methods are similar to Lua methods. I don't know about Lua methods. They take a self as first argument. Okay, okay. Yeah, Rest doesn't do that because technically I don't think objects have references to methods. Methods are just functions with some extra syntactic sugar. And when you are saying syntactic sugar, you mean, but syntactic sugar, you're saying syntactic sugar. Syntactic sugar. mm, Syntactic sugar. Okay, I don't know about Rust, but I'm going to say that I don't think syntactic sugar is the right word because methods have internal definition to them. That is what should happen whenever you call this min function and max function. And like in C++, yes, hello.cpp, this thing, cout I, this is syntactic sugar. This thing is syntactic sugar, and you can not often, you can always remove the syntactic sugar and cout dot put or call or get, wait, there is a like literal thing, clear, bad, right. Expected two things. Yep. I mean, this thing is this shit. No. This is Shit. Okay, this is the syntactic sugar, and this is the actual thing which this syntactic sugar translates to. But if you are saying that these functions, or yeah, these methods, wait, this is a literal function, this is not a method. Methods are syntactic sugars, then you should be able to rewrite that syntactic sugar into the actual thing which that syntactic sugar is abstracting away. I think that is the thing. Like you can call type method instance of type. Okay, yeah, I think I should just read more things because I don't know about Rust. This is nice. This is nice. Types are namespaces too, and I want to just clear this. This thing. Methods are references to definitions. An object has references to methods which were defined in the class to which the object belongs to. That is what is happening in a object-oriented language. But in Rust, the concept of class and method, class is replaced by namespace, and we are treating types in as a sort of class, you could say, and every variable for a type as the object. And a class has methods. Here, since we are treating this type as a namespace, this namespace, type namespace, is going to have functions. And when we call a method on a type which belongs, when we call a method on a variable which belongs to a type, we will call that function. Okay, let's see this. So there are like two things, object-oriented model and the Rust model, and we are trying to translate things into them. And we don't even know what the literal thing is, what actually happens in the object-oriented model or what is happening in the Rust model, but we are just trying to still translate between the two things. Okay. Our own type, new. Shit, we can do this. Our own type, we can create our own types in Rust. Some method is equivalent to our class, some method x. Okay, shit, this is the exact thing which they have done here. This and this. Okay, okay, so I get this part that this thing calling with a dot and then the method name is syntactical sugar for this. Okay, and that is, yes, that is syntactical sugar. That is syntactical sugar. Okay, okay. Make types with structs and enums, and we can even give them functions, methods. That is nice. That is nice. Okay, anonymous kitten 47. Okay, that is nice. Okay, that makes sense. But when I got confused, it was because you said methods are syntactic sugars largely, because methods are not syntactic sugar. The way that we are calling the method is syntactic sugar. Here, this way of calling the method, the syntax of calling the method is syntactic sugar, but the method len, the definition for the method len itself is not a syntactic sugar. Just the way that we are calling it, that is the syntactic sugar part. Think. Let's move forward with this. Wait, we are not even close to end. Shit. Okay, okay, I guess we won't be able to complete this in today's stream, but yeah, we are understanding things. That is nice. Step by step. str is a primitive type, but many, okay, before moving on, this thing, this, we can call things like this, okay. Save, save, shit, yes, we have to save the file, shit. Uh, let x equals I there, that is fine, and let c equals x dot len, save, okay. C is not being used, print ln, this thing, and length is this c. So there is this way, or we could say c equals str len x. We could also do this. Unused variable, yeah, does not matter, that is fine. Okay, there are two ways to call a method on a type, and types are also namespaces. That makes sense. And I will have to go to the washroom. I'll be right back. Why not CP today? CP was getting a bit too overwhelming, so I'm taking a break for a few days. And in the break, let's do Rust. Why not? Yes, I'll go to the washroom and I'll be right back in a minute. Yo, do the back. Bro's thinking. Yes, yeah, C++ was getting a bit overwhelming. Competitive programming, so a break for a few days. But a method is functionally identical to a function. Functionally identical to a function that takes that thing as a first argument. Makes sense, makes sense, makes sense, makes sense, makes sense. Type, method, instance of type, or if we are calling it like this, yeah, we don't have to okay, shit, yes, this makes sense. This is similar to Lua. This is similar to how methods are in Lua. Makes sense. Where the variable on which we are calling the method, it is passed as the first thing. Okay, yes. When we are calling this dot method on this, x is passed in as the first variable. And when we are explicitly calling this for the type string, x is passed in. We have to pass in x manually. Okay, makes sense. The libstd standard library, prelude. Okay, prelude. str is a primitive type, but many non-primitive types are also in scope by default. Not a primitive type. Primitive type string would be like a literal string in C++, like in normal C, null terminated string, something like that, primitive type. But many non-primitive types are also in scope by Default. Okay, by default, these things are in scope. Okay. Vec is also in scope. We can just use it without importing anything, without calling std vec or anything. Okay, vec. Okay. So we can use str out of the box without using any double colons. Vec is a regular struct, not a primitive type, and we can just use it. This is exactly the same code with full path to vec. Okay, and a regular structure. A regular structure in the sense it has a pointer in the heap which is storing the actual data. This works because Rust inserts this at the beginning of every module. Wait, this works because Rust inserts this at the end of every module, at the beginning of every module. Okay, and this inserting this at the beginning of every module also means when our file is compiled. You are a web dev. I am not a web dev. I've done some web dev things, but not explicitly. Yeah, but I've done web dev things. I will have to get better at web development, make websites. This thing would also be added at the top of our own little program. Capital V. And okay, there is some error type annotation needed for this. Comparison operator. Okay, okay. Let's not run too fast, which in turn re-exports a lot of symbols like a vec string operation result option result. Structs are declared with the struct keyword. Okay, x and y float 64-bit, aka double precision. They can be initialized using struct literals. Okay, v1 equals this, where this is the data. X, which was defined here, equals to 1.0, and we can change the order, does not matter, only the names do. Okay, so we explicitly have to say X is this, Y is this. Okay, okay, okay. Struct my st. X is something of type 64-bit float, and Y is something of type float 32. Okay, something messed up happened. Capital, camel case, save. It is never used. Okay, and should have upper camel case, so they have a type preference. Rust C. Okay, there is a code action, and there is no code action. Rust C convert the identifier to upper camel case. Save, always save the file. Okay, and always save the file. Shit, yes. And then let b equals my sp with the first value 1.1 comma second value 1.1. Does this work? This does not work. I have to explicitly say x equals this thing and y equals this thing. These fields are never read. Well, let's read them. X comma y. Okay, s comma x comma y is nothing. D comma x and d dot x dot y. Okay, rest C main dot rs 1.1 1.1. That makes sense. That is pretty cool. Okay, we know about structs now. They are working, and then struct update syntax. There's a shortcut for initializing the rest of the fields from another struct, right? For initializing the rest of the fields from another struct. Okay, v3 is same as v2 except sorry, v3 has x, but it also has all the same things as v2. Okay, this is initializing the struct, not defining the struct. This is initializing a struct. Okay, this is called struct update syntax. Can only happen in last position and cannot be followed by a comma. Note that the rest of the fields can mean all the fields. Okay. Okay. X is given explicitly and whatever is not given, take it from v2. Okay. Destructuring struct structs like tuple can be destructured just like this is a valid let pattern. This is for this function will return a tuple with two values. So yeah, we can destructure the tuple here. So is this. Okay, we have v is a struct of type v2 where the value x is 3.0 and y is 6.0, and then we are saying we are going to destruct a structure of type v2 into x and y, and this is the one that we are destructuring. I think this is redundant. Compiler should be able to know the structure which we are destructuring from the type that we are providing here. Let's see. Let this and this x comma y equals d. Okay, we do have to explicitly say this. Can we not remove this? We cannot. Expected whatever rest analyzer syntax semicolon. Yeah, okay, so this is error. We have to explicitly see which structure we are destructuring, even though we have given d here. Okay, that is kind of strange, but okay, that is how things are. And throw away everything else, just give me the x. Shit. Okay, so this depends on the name. Shit. Okay. The name that we are using has to be the name which we used in the structure to define the thing. Okay, here we used x and y variable names to define things. Here we cannot use anything else. We must use x and y when we are destructuring something of this type. My t x equals 1.1 and y equals 1.1. Okay, this also works. That is nice. That is nice. Patterns and destructuring. Destructuring with if let. Let patterns can be used as conditions in if. Let patterns can be used as conditions in if. Can be used as conditions in if. We have a structure, odd and value, boolean. Okay, function let 1 equals a number, odd true value 1, odd false value 2. We have two numbers. Print number. This is a function which takes n, which is a number, and if let number odd is of type true and value is of type value, value is whatever type, equals n. If n is odd, then print odd number and print the value. Else if let odd false, should, this is crazy, this is crazy. What is the thing that is being evaluated here? Let patterns can be used as conditions in if. That is crazy. You can also make structs with nameless fields with this instead of this. Shit. We can also make structs with nameless fields with this. So like something like this. Or field is nameless. Z, missing Z. And this is like null, I think. Z is not being used. And yes, let's print Z. Doesn't, it's okay. The println function does not know how to print Z. Always save the file. File. Okay, but that other syntax, this thing is okay, this is kind of hurting the head a little bit. If let is yeah, really weird, but yeah, really useful. Struct okay, we can use structs with, wait, define, make structs with nameless fields. Struct, okay, we can define structs with nameless fields, I32 and F64. let x equals my st, and do I give numbers like this? 10, 1.1, or with this? Okay, this is fine. Okay, that is how we make a string. X is not being used. Okay, now with 0 and 1. Okay, so if we do let a comma b equals x, my st, how do we destruct something like this? How to destruct, or like unbinding is the technical name, destructure. Yeah, how to destructure in a unnamed struct in Rust. Rust by example. Yo, let's go. Destructuring structures. This makes sense. And Z is a tuple. And shit, we can define a structure. Wait, this is real time. Shit, I can change this. Okay, and here we are defining a structure inside a function. Okay, we cannot do that in C++ or C. That is nice. But what if the structure is like this, defined like this? How do we destructure something like this? Fa equals foo this. Destructuring. Foo is foo. Okay. Pattern. Okay, let's get into this thing. Let. We can use let pattern as a condition in the if statement, and that is crazy. We can use let as a condition, same as assigning. Yeah, oh, okay, okay, shit, okay, that is cool, that is cool, that is working, that is working. Not see out. First, second, and then a comma b. Always save the file. Rest c main.rs dot slash out. Yep, working amazingly. Okay, okay. Named. If we define a named structure, x has type 132-bit integer, and this is also a 32-bit integer, let's say, and then let y equals named where x equals some number and y equals some other number. That it works. Camel case. Camel case. X and y are not used. X and y are not used. let's say z, and okay, let's also destructure this. Let named x underscore y equals, okay, this makes sense. This makes sense. This is the same way that we were defining something here, and now here we are destructuring it in the same way. Underscore bit, underscore x, and this is underscore z, not z but y, and x is not being used. Rust compiler main, yeah, working amazingly. That is cool. That is cool. Let my struct, yes, it is working. You can also put a and b in the curly braces for the print ln. Okay, we can put them inside the curly braces. Shit, okay. Mm, that that does make sense. That makes more sense, or like this is more convenient than putting stuff at the end of the line. That is cool. And this thing, shit, okay. Here, okay, we are destructuring n, and we are getting value and odd. And if these two things are same, what is even happening there? Let's say 5. Hmm. Let's say let named underscore x, uh, uh, named x value 5 or 10 comma y equals underscore z comma y. Think this should return true, because here this value matches with, and this does not matches. Found let only supported directly if condition of if and while. Okay, so we cannot use let here. The spam saving, spam saving. Uh, yes, the spam saving, yes. So always save the file. Okay, we cannot use let here. Sad. Look at this. The whole line is gone, but the error is still there. If let named underscore x 10 and y any value, y can have any value, equals named, shit, not named but underscore z. If this thing is true, then println truth, and y. else we still need the value, uh, we still need the value of y. So let else if let named destructured x type anything else which is not 10 y equals underscore z, then yeah, same line except false. Main out, okay, dot slash out 209 and true. Okay, and if we change this, not gcc, rest c main run it false, and it's true, I think nothing would print, and instead we can print whatever the value is. Okay, or if let pattern, okay, rest c irrefutable if let pattern, uh, if let pattern, this pattern will always match. So if okay, I want it to match no matter the value of x. Like this is not a bug, this is a feature. It does work, but wait, is this the thing that is running? Rest C. Yes, this is the code that is running. That is nice. We are getting the value of y no matter what the value of x is. Okay, or we could be like better human beings than this, and we can put this thing inside. Yeah, this is better and with no errors. Rest C main rs dot slash out. Cool. This does work. That is nice. Okay, okay. Okay, and yes, the interpretation of this thing, it just means, I think, that if whatever value we have provided, if this value, when we destructure n and the value that this odd variable name, which we defined here in our structure, is equal to the value which we have provided here, then this results in a true value, and we get into this if statement. That is nice. Okay, and otherwise if the destructured value of n is different from this value, then it is false, and we go here and we check this statement, else if. Okay, we could also use this as a match, like switch statement. Okay, this makes more sense than that thing. When we destructure n and the odd value equals true or the odd value equals false, we are also getting the value. Okay, let's do switch. Or switch, not switch, match. if named underscore z has a value of 1 and y, whatever value y has, do this println value underscore y. Cannot find because y is small. Ensure all possible cases are handled. This is not exhausted. Name underscore x2 if the value is 2, and whatever the value of y is, then also print ln value of y. We can share the all the possible values that x can have are a bit too much. We cannot handle all of them. If true, then this. If false, then this. Now, all the possibilities for underscore x have been handled because there are just two cases, either x is true or false. Okay, that is pretty nice. And let's change this later and say that this is false, and then recall this. Press C main rs dot slash out true and false. Okay, yeah, nice. That is working. That is working. Okay. Okay. Shit. This was okay. Okay. These things are slowly making sense. This has been a lot of information. Yeah, shit. Literally a lot of information. Let's see how much more we can take. Structures, update, syntax, patterns, destructuring. Yes. Let also acts as a true false value. It can be used as a condition in if statements and also in match arms as in conditions, as in different things that we are catching in a match statement, where comma is acting as the break statement kind of thing. A match has to be exhaustive. Yes, we did see that. A match has to be exhaustive. At least one arm needs to match. If this, or if anything else, then value. Shit, and here we only need the value, so we don't need anything else. Function print number takes a number, and we are only taking value, and we are throwing away everything else. And now this will always turn out to be true. Okay, if that is hard, this can be used as a catch-all pattern. And dot value. This also makes sense. For one, do this. For two, do this. And catch-all, do this. Every other case, type the like integer representation of a number. Then methods. You can declare methods on your own types. That is crazy. We can declare methods on our own types. Yo, let's go. Oh, I remember learning guards for OCaml. Yo, what is guards? OCaml. OCaml is a nice language. Shit, I've heard people say very good things about. Shit, look at the time, 3.14. That is nice. Bye. I've heard people say very nice things about OCaml. Primogen specifically. OCaml is a nice language. OCaml. OCaml. Share. Yes, I will also learn OCaml. That would be nice. OCaml. So this is a video. This is a video. Things are moving. How does it look like? Not VS Code. This is how OCaml looks like. This is just an error in OCaml. Yeah. Shit, this is also a video. How is a video coming here? This is okay. We use let in OCaml. Okay, we have string, we have boolean, and shit. It's just this thing where you have to literally move your cursor onto the variable and see the type. You don't have to do this in Vim. And just go there and type whatever your key mapping is. This is of type this, and this is a boolean type. That is nice. That is just very nice. OCaml is wacky but interesting. OCaml is also very low level thing, low level programming language. And yes, when Primogen went to Lex Friedman's podcast, he was wearing a OCaml t-shirt underneath his jacket, and that was nice. OCaml. I think OCaml also has a cult, um, cult as in we have Vim cult or Arch Linux cult. I have an Ox Camel shirt. Ah, shit, Ox Camel. That is shit. Programming shirts are pretty cool. I use shirts which say I use Arch by the way or something like that. They are very cool. You can declare methods on your own types. That is crazy. Impel, shit. Impel down, implement or tame impala, implement number. And yes, Eric, do you listen to Tame Impala? I guess you should, or yeah, of course you also yeah. I think you do listen to Tame Impala. You are from Australia, so yes, that is nice. Tame Impala. Implement on the number structure a function named is strictly positive, where the first argument is self, and this function returns a Boolean type, and this is the definition for the function. Check the value is greater than strictly greater than 0. I think that is how. I know a little of Tame Impala. Yeah, what kind of music do they make? Okay, Tame Impala is not a they. Tame Impala is a single man. Yeah, that is not a band. Tame, everything you listen, whenever you listen to a Tame Impala music, the vocals, the sound, drums, sticks, whatever the thing is, that is a single human being doing everything. His name is Kevin Parker, and he does everything, and that is crazy. And his music is, you could say, different and not just different. Yeah, yes, that is what I meant. That is a singular human being. Tame Impala is a singular human being. And yes, the music that he makes, it is different. It is different. Use psychedelic music. Psychedelic music. Psychedelic music is one term you could use. But I don't know how to like, explicitly explain music. Yeah, psychedelic, psychedelic music, and his lyrics are amazing. His lyrics are amazing. You must have listened to his songs like Let It Happen or other songs. They are amazing. And he has an album coming on 18th of October. Today is 12th, 5 days later, and it will be cool. And this is how we define a function, a method for our own structure. And okay, and we can think here of namespace of number as a namespace. in which we are adding this thing. Okay, let's do some experimentation. Not int main, main, and we will have a struct which you can have inside our main function. Struct on my st. This will have value of I32 type. Okay, and let x equals my st where the value is 5. Now they will say x is not being used or field in this struct. Value is never read. Print ln x dot value. X dot value does not work. Not used better. But field in this struct, what is that? X dot value x dot value x dot value does not work. X dot value doesn't work. Somehow it is just not working. Dot value. Yes, this should be working. My struct print ln 5 x dot value. Okay, we cannot use x dot value inside here, but we can use it outside. Invalid format string field access isn't supported in formatted string. Okay, let's implement implement in my struct. Yes, implement in this struct a function. Fn is big, and yes, the first thing is self and returns boolean, and self dot value is greater than 3, not a semicolon. Is big is never used, and method in implementation. And after declaring this, if x dot is big, if x is big, we will print x. Borrow of moved value x, value borrowed from after move. Shit, there is some ownership shit here. implement function. This is the type, this is what it takes, this is what it takes, and returns a Boolean thing. And internally we are just, yeah, this is the definition for the function, and use them like this. Let minus equals number, also value is positive, minus 2 dot is strictly positive. This prints positive false. Okay. So my guess is when we call this method, our variable x is gone. We cannot use it any longer. So if x dot is big, then print ln big. Okay. But if um let's say 5, this does work. But if we were to use x again, x dot value, this will give error. This will give error because somehow x is gone. When we called this method on x, x is gone. We cannot use it any longer. X does not belong to us. Hello. How is everything? Okay, that is cool. That is cool. Immutability. Okay, that is the next step. Shit. This is getting a bit too much. Shit. Yeah, we have read a lot of things. Shit. We have gone through a lot of things. And there is still quite a bit left. And it has been 3 hours and 27 minutes. That is a long time. And I guess now would be a nice time to stop taking in information and yeah, just take a break from this. We have, let's revise what we have seen. Yeah, let is the keyword to define new things. Type annotation, we can explicitly tell the type or we don't have to, like this. And we cannot use a variable without initializing the value, but we can after initializing the value. And we can throw away some value using this thing, underscore. And shadow binding, we can redeclare a variable of the same name, and this is kind of like shadow binding. But in other languages also we have shadow binding, but it is different here because in other languages the shadow exists inside a smaller scope, which is contained inside the larger scope where the outer variable is the original variable was declared. But here we can have them in the same scope. And we have tuples, fixed length collections of values of different types, not like necessarily different, but yeah, they can be different. And we can access members using 0, 1. Syntax, we can also destructure a tuple like this. Let first value will get to this thing, second value will be given to this thing. And we can capture and destruct return types, return values of a function like this. Or we can also like throw away something. Statements end with a semicolon. And yep, functions, we define functions with the fn keyword, and the function name, input output type is defined like this. And if we, yes, blocks are also, yeah, blocks are there, we can have blocks. Blocks are also expressions. If we a block returns a value, and that value is the last statement which does not have a semicolon. If we have multiple statements in a block, then the last one, the tail, is what the block will be evaluated into. And that is why this thing works. Returning from a function like this works. Everything is an expression. Everything is an expression. If else statement is also an expression, that is, which is just crazy. Yeah, which is just crazy. If this thing is true, then return this, otherwise return this, and whatever is returned by this would be returned by the function fair dice rolls. A match is also an expression. Whatever is uh, so a match also returns something, and the if statement itself, if else pair, also returns something, which here could be 6 or 4, and here also it could be 6 or 4. And match is handling this feeling lucky thing, and if feeling lucky is true, this is what the match will be evaluated to, and if feeling lucky is false, this is what 4 is the value that match will be evaluated to and will be returned by this function. Dot. We use dots to access some elements inside a tuple or something, to get access to a field of a value, or to call some method, or to call a method like this. Yeah, call a method. And then modules use this syntax. Yes. Here, this is a library which has a module which is just a file, and this file has a function like this. And std is a namespace. Use directives. If we don't want to explicitly do this, we can call use, and use can have different things. It can have a wildcard, or it can have, like saying from the standard library, the compare module, import or use these two functions. And types are namespaces also. Yes, that is a crazy thing to say. Types, this type is a namespace, and it's this has like this is syntactical sugar. What is this? From where are you reading this PDF type? Okay, this is here. This article on Rust. Types are namespaces too. So namespaces or types are namespaces, and they have functions. Yep, methods, and we can call them. And when we call a method on a type like this type, the value of this type is given as the first argument to this thing. And yeah, some things are already like present without using the use statement. Use declarative. We can use some things already, and vec is one of them, and we can use them because the Rust compiler by default adds this statement at the beginning of every module. And then there are structs which have their own crazy things, patterns and destructuring. Yes, we can use let for conditioning, which is crazy. Yeah, exhaust. Yes, match has to be exhaustive, and if that's hard, catch all. And then we can also define a method for our structures. That is crazy. And yeah, this is the point till where we have covered all the things above, and that is nice. Messed up language. I was lurking for quite a bit, and I found out Rust is nothing but a problem. How can you always have opinions about things which you might not know about? You said that you don't know Rust. Rust is nothing but a problem. I mean, everything is nothing but a problem. Everything has problems. Yes. But it is also solving a lot of other problems with its own problems. And shit, yes, Rust is difficult to get into, and that is why I guess people should learn Rust. Too many new words just because it is new. Globs, arms, globs, arms, arms. Arm is nice. Arm makes sense. Globs. Shit. Yes, we did saw globs. What were globs? Globs were in namespaces. Namespaces. Yep, globs. I love Rust. Shit, how many people hate Rust for the same reason? I love it. Yo, um, shit. I guess this would feel pretty cool. I mean, if you can write Rust fluently or with a sense of familiarity, and other people are struggling with the same thing, this must feel cool, right? When you are using Vim and the other person doesn't even know how to just move the cursor, it just feels cool. It feels like your hard work paid off. And yeah, not to make fun of the other person, just to feel cool, right? It means your hard work paid off. Yo, yes, bro is the mentor. Bro has been telling a lot of things. That is nice. And thank you for all of that. Those words don't make sense. That is like what part of that is the problem? Everything new does not make sense. Like, ich kann ein bisschen Deutsch sprechen, aber mein Deutsch ist nicht so viel gut. Aber ich jetzt Deutsch lernen und yeah, that is the accent of my German. But when I was learning German for the first time, things didn't make sense. But you learn these things, like that is obviously, yeah, things don't make sense when you're learning them for the first time. Same art. Why? Okay, I think we can shit on Java. I don't know why people would learn Java. And yes, shit, now I am being a hypocrite because I said you should not shit on Rust because you don't know Rust. But I don't know Java and we can shit on Java. Nope, it boosts. Yes, it does boost the ego and makes you like, yo, yeah, it does boost the ego. Although it has a lot of boilerplate, Java is good. Okay, shit. I guess you would be better at shitting on languages than me. Can you shit on Java a little bit? Let's see. Is Java good? Shh. Not even is Java good. The first question comes up, is Java really that bad? Shit. I mean, programming nowhere. So I am going to be dividing in diving into coding, and I joined some subs and they keep making jokes about Java being extremely difficult. Okay, if that is the case, does anyone have any good resource, quick tips on it? I used to play around with code as a little kid, but I don't know. Shit, is Java really that bad? Wait, if you're calling Java bad and your only reasoning rationale for that is Java is difficult, extremely difficult, then the same rationale can be applied to Rust. Yes, you. Ah, Java is boilerplate oriented programming. You cannot write a function by itself in Java. You have to have a class. Like that is crazy restrictiveness. It is kind of opinionated. And you would argue that Java is a bit verbose, which is both good and bad. Why are they not sitting on Java? Java is boring, verbose, boilerplatey, yes, monotony, and this means a few things. A lot of developers are going to hate it. Enterprise is going to love it because verbose. It is great for learning programming. And okay, what should confirmation bias? I will just look up things which prove my point that Java is bad. What percent of things are made in China, made in Java? 90% would not be. thing. Shit. Shit. Um, uh, why is Java bad? And how does it feel to write static void like a billion? Yes, that is bad. That is bad. That is very bad. That is very bad. This is removed in current versions of Java. Uh-huh. Though, because I assume English isn't your native language, so you learned English well enough to stream in that language and know some German. Yeah, thank you. I am an Android dev using Kotlin, and I can get worse than this. I can go worse than this. Shit. Go all the way, I guess. And yeah, I've been streaming for a while now. Yeah. And yes, German. I learned German. I am learning German because, of course, there is only one reason. This is the only reason you would like to want to learn German, right? To watch this thing. I have watched this in German, but with subtitles. I want to watch this in German without the subtitles. That would be nice. And also read a book, which is The Spoke Zarathustra by Mr. Friedrich Nietzsche. Yeah, that would be nice. That would be very nice. And yeah, null handling. No, I don't want to go to Germany. I just want to watch Dark. 48, there are 48% taxes. Sick. 48% taxes in Germany. That is a lot. Shit, literally half of your money is going to the government. That is crazy. German taxes. Drunati. Nope. Yeah, I'm not going there. I mean, if I could, I would like to go there and then come back. But the money is worth it. Okay. Germany. Shit. Java is banned. Just trust me, bro. Yeah, that is the benchmark. Trust me, bro. Check what you can get. What do you mean? Check what you can get. Okay, like take money, cash, check, or yeah, if you are taking your salary, get it in check, I guess. German tax benefits. This doesn't feel beneficial. 48% taxes. Okay, that has been long enough. Google it. German, uh, not literally Google. Deductions, PWC, and uh, mhm, employee expenses. Individual deductions as in how much money they are taking away from you in forms of tax, various properly documented and necessarily incurred income related expenses may be deduced by an individual unless they are in the case of employment relationship reimbursed by the employer. Various properly documented and necessarily incurred income related expenses may be deducted by an individual unless they are in case of employment relationship or reimbursed deducted by an individual. Uh, does this mean that they do not have to pay taxes for various properly documented and necessarily incurred income related expenses, like a company does not have to pay tax on something they are buying for the company, sort of like that? or by deducted means the government will charge money on things like this. For employees, common tax deductions include costs of traveling to and from work. Business literature. What is business literature? Studying rest documentation, I guess. That is business literature. Professional dues. Dues. No, I read it as duels. Professional duels. Work equipment, laptop. Starting from the assessment period 2023, employees who have switched to remote work are allowed to deduct EUR6, whatever that is, for each calendar day working from home, whereby the total sum is limited to EUR per calendar year, and thus the limit of days to be claimed is this. There is a blanket employee allowance for business reductions. Okay, I don't get all of this, but I think this means as a person, I can tell the government that I do not want to pay tax on things which are in these categories. If I'm buying a laptop for my work, I do not have to pay tax on the laptop. If that is it, what is PWC? Worldwide taxes. Is it bad? Is it like Java? Is the full form of PWC Worldwide Tax Submission Online? If that is crazy. Should I go to some other website? Rates, tax, Germany, import. Bro, are you from which college? I am from a local tier 3 college near my house, AKTU affiliated college. Yeah, that is like nice. Okay, okay, okay. I don't have to pay taxes for all of those things in those categories. That is nice, pretty cool. And yes, I would like to end the stream now. It has been long enough. I want to like take a little bit of rest and do some muscle ups. That would be nice. Yeah. And that would be the end of today's stream. And thank you for being here. Bye.